In this session, we will focus on implementing vector search in Task Manager module. Traditional search mechanisms depends on exact keyword matching. However, in modern application, user can search using different words that carry similarity meaning. To address this challenge, we will use vector search which enable semantic search capabilities. In this session, we will develop intelligent search API using Node.js, Express.js, and MongoDB, allowing user to retrieve relevant tasks based on meaning rather than the exact keyword. By end of this session, you will be able to understand the concept and implementation of vector search in the Task Manager module, develop backend RESTful API for semantic task search using Node.js, Express.js, and MongoDB, understand the difference between traditional keyword search and vector-based semantic search, generate vector embedding from task title and description, implement cosine similarity calculation to identify relevant tasks, retrieve semantically similar tasks even when exact keyword are not present, display ranked search result dynamically based on similarity scores. This session introduces AI-powered search technique that significantly improve user experience in modern applications. Now let us understand the algorithm used to compare vectors called cosine similarity. The input to this algorithm consists of query vector represented as Q and task vector represented as T, and the output is a similarity score. The process begins by converting the user search query into a vector representation. Next, the task title and description stored in MongoDB are also converted into vectors. Once both vectors are available, we calculate the dot product between the query vector and the task vector. The dot product helps to measure how these two vectors are closely related. This forms the first step in determining semantic similarity. After calculating the dot product, we calculate the magnitude of both vectors. First, we calculate the magnitude of query vector, then calculate the magnitude of task vector. These magnitudes represents the length of each vector in multi-dimensional space. Once we have the dot product and vector magnitudes, we calculate the cosine similarity score. The similarity score is obtained by dividing the dot product by the product of both vector magnitudes. Finally, the similarity score is returned and tasks are ranked based on this value. The tasks with the highest similarity score are displayed to the user as the most relevant search result. This approach enables semantic search, allowing user to find relevant tasks even when the search query does not contain the exact word stored in the database. Let's start implementation. First, go to the project location and delete the folder frontend underscore repo. We can get the latest version from the Git repository. Then open command prompt for this location. Click on address bar and execute the command cmd. Once command prompt is opens, clone the repository by using the command git clone followed by the repository URL. Repository URL given in the video description. Once the repository is cloned, we can close the command prompt. It creates a folder frontend underscore repo. Enter into the folder and choose latest version 7.0. The version 7.0 will have both frontend and backend applications. Let's start executing one by one. So open frontend application in VS Code. Then add a terminal. Convert the terminal into command prompt mode and install the dependencies because the project is recently cloned from the repository. So use the command npm install to install all the dependencies. Then start it execution by using the command npm run dev. Then enter O. It opens output on the browser. Then go to the project location, enter into backend folder, open gateway project in VS Code. Then add a terminal, Convert the terminal into command prompt mode. Since the project is recently cloned from the repository, we must set up the virtual environment by using the command python space -m venv followed by venv. Once the virtual environment is created, then activate it by using the file activate from the location venv scripts, then the file name activate. We can install the required libraries from the file requirement.txt by using the command pip install -r followed by requirements.txt. Then started execution by using the command python followed by the file name run.py. Then open the project core services using Spring Tools. So make sure the workspace location for Spring Tools from the version 7.0 backend. Then click on launch. Once the Spring Tools is opens, then import the project. Go to File menu, Import, inside Maven, choose existing Maven project. Click on Next, then click on Browse and go to the location version 7.0 backend. Choose the project core services. Click on Select folder, then Finish. Once the project is imported completely, go to the project and choose src main resources. Open the file application.properties. Update your database password. And then save, close and start it execution. Right click on your project name and use the option Run as Spring Boot app. Once the execution is started, then open the project task services in VS Code. So go to the backend folder, choose the project task services, open it in VS Code by using the command code space dot on the address bar, and then add a terminal, convert the terminal into command prompt mode, then open .env file, replace your MongoDB connection string for DB URL, then save, close, right click on the folder services, create a new file vector service.js. Then open the file in the editor and start implementation. For implementation, we need to install a library. So go to the console and execute the command npm install followed by the library name @x innova/transformers. Once the library is installed, we can start implementation in the file vectors service.js. Import the function pipeline from the library xnova/transformers. Then create a function to generate a vector. I just name the function as generate vector with one parameter, the query in the form of text. Then create a object extractor, initialize by using await pipeline with two parameter. One is future extraction and second parameter is the model name x innova /all hyphen mini lm hyphen l6 hyphen v2. So the second parameter is case sensitive. It should be entered properly. Then create object feature equal to await the object extractor and pass two parameter. One is the text available in the parameter text and second one is a JSON data with the two keys. One is pooling set value as mean, and second one is normalize and make it as true. Then finally return the vector array by using array dot from the object feature dot data. The function generate vector takes input in the form of text and extract the future and generates a vector array. Then create a function to calculate cosine similarity. Export function cosine similarity. It takes two input, one is query vector and another one is task vector. Then create a variable to find out the dot production of query vector and task vector and initialize as 0. Then create another variable to calculate magnitude of query vector as well as magnitude of task vector as discussed in the presentation. So I just name the variable as magnitude 1 and initialize with 0, and create another variable magnitude 2 and initialized as 0. Then use a for loop, set the index variable I equal to 0 and it should be repeated until the length of the query vector q dot length, and each step value of I is incremented by 1, so I plus plus. Inside for loop calculate a dot production, so use the variable dot plus equal to q of I multiply with t of I. Then calculate magnitude 1 plus equal to q of I multiply with q of I. Next calculate magnitude 2 plus equal to t of I multiply with t of I. Next to the for loop update magnitude by using math dot square root magnitude 1. Then magnitude 2 equal to math dot square root of magnitude 2. Then check for the condition. If any one of the magnitude is equal to 0, we should not perform division operation. So check the condition magnitude 1 equal to 0 or magnitude 2 equal to 0, directly return 0 as a result. Else return the cosine similarity score. So by using dot divided by multiplication of magnitude 1 into magnitude 2. So we implemented a method to find cosine similarity score between query vector and task vector. Then save and go to the file task service.js, import vector service.js here. So import star as vector service from /vector service.js. Then go to task.js from models package. We need to add one more field to save the vector for title and description. So next to created by comma, add a new field with the name vector and set its type as number array. And don't make this field as a mandatory field. So no need to add required :true. Then save and go to task service.js. Inside create task. Before performing insert operation or update operation, we must generate a vector based on title and description. Store the vector into the database for vector search. So calculate data.vector equal to, by using the object of vector service and call the function generate vector and pass data.title concatenate one white space, then concatenate data dot description. So this is the statement is used to generate a vector based on the title and description to store the vector into the database. And also go to update task function, calculate vector before updating. So data dot vector equal to await by using the object vector service dot generate vector and pass data dot title by concatenating one white space and concatenate data dot description. Then go to the end, create a function to perform vector search. It takes two parameters. One is query to perform search and another one is token. Inside, create a response object and implement try catch to handle the exception. Finally, return the response. Inside catch block, set response as code 500 and message from e.message. Then go to try block. First validate the JWT token. So create object payload equal to by using the object of JWT and call the function verify and pass received token as an input and its secret key. This is for authorization. Next, generate a query vector. So create object query vector equal to by using the object of vector service and call the function generate vector and pass the received query. Then perform read operation. So constant task equal to by using the object of task.js and call the predefined function find with a filter created by assign value from payload correlation id. So payload dot crid. After a read operation, we must apply a vector search. So create an object constant search result equal to use map to iterate over all the tasks from the database. So task.map. Inside, create arrow function with the object task. Inside arrow function, calculate the similarity. So const similarity equal to by using object of vector service and call the function cosine similarity and pass query vector and task vector as an input. So query vector is already calculated. We can pass the value of query vector, comma, and value of task vector. So use the object of arrow function task dot vector. Then add a console log. It's not mandatory, but it will give information about the score generated for each task. So console.log task.title, comma, similarity. Then finally return the task by updating the field similarity on it. So use the spread operator for task dot underscore doc, comma, similarity. Then at end of the map statement, apply a filter by using the function filter and set task similarity greater than the threshold 0.10. Next, sort the result based on the similarity score in descending order by using the function sort. Inside, create arrow function with two parameters a comma b and sort based on the similarity score in descending order. So b dot similarity minus a dot similarity. Next, call the function slice, set a range 0 comma 5. This helps us to take top 5 highest similarity. Then set a response equal to success code 200 and task data from search result. The function vector search is used to perform a search operation by calculating cosine similarity between query vector and task vector and returns a result. Then save and go to the package controller task controller.js. Add a new endpoint for vector search. So router.get, set endpoint name as vector search with path variable query and add arrow function with two parameter request comma response. Inside arrow function, extract the value of path variable. So constant variable name query equal to request dot params. Next, create object to receive the response equal to await by using the object task service and call the function vector search and pass the path variable query and received token from request dot headers dot token. Next, return the value of response by using res.json and pass the value of response. Then save and start it execution. Go to the terminal, use the command npm start. Then go to the project gateway and open the file task controller.py. Inside controller, add a new endpoint for vector search. So we can copy the previous endpoint and paste it, change the request name as get and update the endpoint as vector search and change the path variable as query. Change the function name vector search and name of the parameter query, and also change client.delete as client.get and update the endpoint name for node.js. And pass the parameter query here. Then save and go to the front end, login with admin credential and go to the module task manager. These are the tasks created before generating vector based on the title and description. So perform update operation for each task to generate a vector and store it in the database. So click on edit icon, just update, then second one and third and then fourth and then fifth. So if you perform update operation, it generates a vector based on title and description and save the same in the database. So inside Node.js project, inside task service, inside create task, we generated a vector based on the title and description and saved in the database, as well as inside update task, we generate a vector and save the same into the database. So if we perform update operation, it generates a vector and save the same into the database. So open a new tab, go to MongoDB Atlas login, then click on Data Explorer, connect with the cluster and go to the database MTH and open the collection task. Verify all the record having a field vector with its value. Second one, third, fourth, and then fifth. So all the records are having a field vector with its value based on title and description. So we can perform search operation. In the front end, there is a provision to perform vector search. Here I can enter the keyword job. The keyword job never present in my title and description anywhere in the all 5 tasks. If I click on search, it will generate a cosine similarity and bring a record related to its semantic. The synonym for job is task. So out of 5, these 2 records matched for the query. So it returns the 2 records. Let us try by changing the keyword. I just enter the keyword as guest. Then click on search. The keyword guest never present in the title and description, but it brings data from the database. So guest, another meaning is user. So this is the query matched with its similarity. So it returns. Then let me try for the keyword page search. It brings a record design website for hackathon. The keyword page is never present in the title and its description, but website having a page. So the vector search what we implemented is working perfectly by generating its cosine similarity and brings data from the database. We can see the similarity score for each task on the console because we added the statement inside vector search console.log to display task title and its similarity. Out of this 5, the last one, design website for hackathon having ISS similarity, it exits the threshold 0.10. So the query returns only the task design website for hackathon as a result. In this session, we have understood the concept of vector search, learned the difference between keyword search and semantic search, understood the cosine similarity algorithm used for ranking search result, learned how intelligent search can be implemented using Node.js, Express.js, and MongoDB.